Hello, everybody. Thank you for joining. My name is Sean Rad, and I do developer relations for Secret Network. Um, I want to start by just kind of telling you about my path into blockchain because I think it's a little bit untraditional. I think a lot of people who come to blockchain maybe find it through an untraditional path because it's not the status quo, although it is starting to become more and more the status quo because of organizations like yourself. I think the world is starting to wake up to the power of blockchain and yeah. So my journey is around like COVID times, I would say. I started reading about Bitcoin, and at the beginning it was just, I had the same knowledge that everybody kind of starts with, which is number goes up, which is what got me excited about it. But then I read the white paper, and from there I just couldn't stop thinking about it. And I wasn't even a developer at the time. I was working in film production in New York City, but all I could think about was Bitcoin and what it meant for the future. And so I was like, all right, I guess I'm going to start learning to code now. And what seemed accessible at the time to me, this is a few years ago, was Ethereum if I were to learn to get started on a blockchain. So I started learning JavaScript in preparation to learn Solidity. Um, and and so my experience is I learned JavaScript, self-taught. Then I joined a Solidity boot camp through. It was all remote, all online, and it was through Alchemy University. It used to be something called ChainShot. Now it's called Alchemy University. And from there, me and some of my classmates, they flew from across the world to New York City, and we participated in a hackathon that summer at ETH, New York, where we built a music streaming decentralized application where through super fluid micropayments, artists are paid in real time, like per second that they stream, they're receiving micropayments. And that was just sort of an amazing experience. There was nothing else that existed like that, in the world, I guess, like or in traditional web 2. And so from there, my mind kind of just opened to the idea of like, this is incredible. I want to be in this community and I want to do whatever I can to ingratiate myself to this community. So from there, our hackathon team won some prizes. We did another hackathon that following month, Hack FS, another Ethereum ETH Global hackathon. And we won one of the Filecoin prizes. We made a ZK DAO. And at this point, I was still a very new developer. Everything I was doing was just learning about blockchain. Um, but I had a terrible experience trying to create UX for this ZK DAO. Everything there was so many buttons that a user would have to click to even be able to use this DApp. And so even though we won a prize, my mind was basically open to this idea that like I think privacy and blockchain is important, but I think the current what it currently exists, the technology stack that currently exists is not very good right now. It's not I can't imagine anybody using it. Um, and for anyone who's like listening right now, if you're totally new to blockchain, one of the beautiful things about it is these peer-to-peer transactions that are decentralized. We don't need an intermediary to allow the transaction to go through, right? Other than just like the network consensus. But the issue with that right now up to this point is that it's a public ledger. Everything, all of our transactions on Bitcoin, on Ethereum are public. Everyone can trace our wallet addresses. We don't have access to private data. Um, and so I first started thinking about this problem when I was making a ZK DAO, and then I started just kind of researching the what was available in terms of privacy tech and Web3. And this led me to learn about Secret Network, where I am currently working. And again, my path to Secret Network was also not traditional. I didn't like apply for a job and then just started working for Secret Network. What happened was I learned of I learned that Secret Network existed, that it was a blockchain in the Cosmos ecosystem, so separate from Ethereum, and that it used something called the Cosm Wasm SDK, and that the smart contracts were Rust based. So immediately, a ton of barriers to entry coming from someone who is just learned JavaScript, just learned Solidity, and I was like, okay, to do this, I'm going to have to learn Rust, a lower level language. But once I started reading about Secret Network, again, it was the same thing with what happened with Bitcoin. I just was like, okay, I'm diving in. And so what happened is I had this idea to build a decentralized business card application that uses Secret Network's tech stack. The idea being that I can create a business card, and then I can only share it with people who I want to have access to it, so that no one else has access to my information, right? Like, because the problem is with your personal information on a business card, right? If it's your name, it's your phone number, it's your home address, you don't want that information to be publicly accessible on a blockchain. And so I was like, how can I be able to share that information with other people and have it be through private transactions? This is what led me to Secret Network. And Secret Network is a blockchain in the cosmos where data is private by default. So we're able to write programmable smart contracts where all of the information that happens on the smart contract, we choose what is actually shared with the world. Let me just allow more people into this. Is everybody following along with me so far? Does this make sense what I'm saying? I don't want to just be I hope this is getting you hype. Um so yeah, and I want to make a quick distinction, which is that some people think that Secret Network, Secret Token is just a privacy coin like Zcash, but the Secret coin is actually a public token that is used to power the network. The token itself isn't actually private. What Secret Network allows for, though, is private transactions in our smart contracts. So the way this happens is through something called a trusted execution environment, which functions like a black box for data processing. And this enables nodes to verify transactions within a block without accessing data that's inside. So basically, just all of the information that is being executed in a smart contract, the nodes are able to verify that that information exists, that this transaction has gone through without actually seeing the information that is that they're saying that they're sending forth, right? So what this brings forth is just like a lot of novel use cases of privacy tech in Web3. And what we're going to be looking at today is something specific to Secret Network called a viewing key, which can be used for access control. So I'm just going to read this to you. Since data is encrypted and private by default, Secret Network users have viewing keys to access their sensitive data. Viewing keys can be shared with third parties like auditors, wallets, and explorers. They allow users to maintain control over the data and decide what is shared and with who. So, for example, in this decentralized business card application that we're going to be looking at today, the way I implemented it is I'm able to create a card that exists on the blockchain, right? So every time I create a card, it exists at a specific index on this in this smart contract, but only users who I've shared my viewing key with are able to access the card that I've created. Um, Let me know if that makes sense. Basically, it's just a password where you can only see the information if you have access to that password. Otherwise, the data exists on the smart contract, but nobody can see it unless they have that viewing key. Let's see. So a few of the things we're going to be looking at today is something. One of the things is called the Secret Network Toolkit or the Secret Toolkit, and this is built and designed by Secret Labs, which are the primary developers behind Secret Network. And there's all of this like APIs they've developed basically that allow users, allow smart contract developers like yourself to be able to develop on Secret Network in a way that is as like user friendly and as developer friendly as possible. So like when I first designed this, for example, I didn't actually know that this existed, but there's a viewing key API that Secret Labs has developed where you can create viewing keys extremely easily in your smart contracts. When I first did this, what we're seeing right here, this is like the behind the scenes of what it actually looks like to develop a unique cryptographic password, right? So like all of this stuff basically is just happens behind the scenes now by just being able to use Secret Network, the Secret Toolkit. And the DApp we're going to be looking at today, there's three primary functionalities. This is like a stripped down, simplified version of the application for demo purposes and for learning purposes. But the three main things you can do with this application, with the smart contract, is create a card, you can burn a card or delete a card, and you can generate a viewing key. And I'm also going to show you how to compile a smart contract on Secret Network and upload and instantiate and execute that smart contract with Secret.js, so with JavaScript. Let me just see if there are any questions at this point. Does anyone have any questions on what I've said so far? I'm monitoring the chat. No? Okay. So I want to just show you some additional resources before we dive in, because if you're interested in learning more about developing on Secret Network, I think these are some of the best resources that exist. And these are all the resources I wish I had when I started developing on Secret Network. So firstly, these are the getting started docs. So these are Secret's documentation. I'm actively working on updating and writing this right now. So if you guys start going through this and you run into any questions, just ping me on Discord or Telegram. And if anything doesn't make sense, let me know so that I can make updates to the docs to make them as developer friendly as possible. But in this getting started section, it teaches you how to set up your developer environment, how to compile and deploy a contract, and how to actually run the application you developed. And it all just uses like a really simple counter smart contract to do that. This is a great resource. I wish I had this when I started. Secondly, there's something called Secret University. And this is another place where you can learn a ton about Secret Network and about how to develop on Secret Network. So there's all of these resources. If you go to the homepage, there's these developer paths where you can start from have a zero to hero journey, where you a getting started section, Secret Smart Contracts 101, implementing viewing keys and permits, and this front end module is coming soon. And also they link to all these repositories that are really helpful. So like SNP 721, if you've built on Ethereum before, you probably are familiar with 721. This is like an NFT smart contract on Secret. SNP 20, it's like a ETH 20 or an ERC 20 contract, but for Secret. So this is a reference implementation of how you would develop your own privacy token on Secret Network. So again, great resource to have. Secret Toolkit. This is what I was mentioning. This is what Secret Labs is actively developing, and what we're going to be specifically looking at today and implementing in our smart contract is, let's see, the viewing key, right? So this is like the actual code that is happening behind the scenes that we don't even have to look at because we're just implementing the API. But I just want you to see that this exists and see the code that we're actually looking at. So this, when we import this module into our cargo.toml file, this is the code that we're actually going to be accessing. It's pretty cool. Let me just link this in the chat for everybody. And okay, this I highly recommend. This is the Secret Network weekly developer call. I lead a call once a week on Mondays at 12 p.m. Eastern time. And the link to that call is right here in these Google Slides. This is just like a free form developer call every Monday where we just talk about news that's happening in the network. Developers can come and ask questions, showcase what they're working on. When I started developing on Secret, I started with this idea for this business card application. I had no idea how to implement it. I started just showing up at this developer call. Through that, I met a mentor who then once a week would work with me to develop this application. I learned the most I've ever learned in my life as a developer through these mentorship sessions. Then now, months later, I'm like an active member in the community, and I'm now leading these calls. So it's like the best thing you can possibly do for yourself if you're new to blockchain or to any sort of developer ecosystem is to just be active, just be present, show up. You don't even have to say anything if you don't want to turn your camera on or if you don't want to ask questions, but just being around, you start to become more familiar, more comfortable, and you start to gain confidence about what you can actually do. Because when I showed up to these calls, I don't know, 8 months ago, however long ago it was at this point, I was so I I guess, like starstruck by the talent of the other developers and just like how much information they knew, how little information I knew. But just showing up and being present and just not being afraid to ask dumb questions has taken me so much further than I could possibly have gone if I was just trying to like work alone, just with the docs and myself. Um, and lastly, we have this business card workshop repository. So this is the actual like repo that I'm going to be working from and showing you guys in case you want to check out the code later on. So let me just take a sip of coffee. Does anyone have any questions about anything I just shared before we dive into the code? I see a thumbs up, which I think means no questions. All right. I'm very clear as a public speaker. I like it. Let's see. All right, can everybody see my VS Code? See some thumbs up. Awesome. Okay. Give me 1 second here as I get up to speed. Let's close some of these tabs. Okay. So this repo that we're looking at, and again, this is in the slides. So if you want to like really go through this on a deeper level after this call and dive into the contract more, you should definitely do that. Um, oh, you know what? Let's do one thing before we dive into this so that it really sets home what we're doing. Um, I want to just demo the application for you guys so you see like what it like looks like. So give me 1 second. I'm gonna stop sharing this. I'm gonna present a window. Okay, let me just show you guys this really quickly. So this is just a simple front end I developed for this demo with Tailwind and React. And all that this is doing is showing us the ability to create a card and then query cards if we have the correct viewing key. All right. So let me just open up my console. So it's letting me know that my wallet is currently connected. Oh, I'm gonna let somebody in. All right. So what I'm gonna do is just create a card just to show you what the smart contract is doing. We live off of Leet Lane. And this card number, all that this is doing, like on the back end of the smart contract, this is just the index in the array where this card is being stored. That's what's actually happening. So let's just save. And now I have to approve this transaction with my Kepler wallet. Kepler is kind of like the default wallet right now of the Cosmos. You guys are probably accustomed to using MetaMask if you've been in the Ethereum world. Approve. So if this transaction is successful, what it should do is return to me a viewing key. So it returns a viewing key, right? And again, if you were to implement this like for users, then you would want to have a way better version of sharing viewing keys, right? Like the OG version I made, that's like the actual app itself. You can scan someone's business card and then it adds their business card to your wallet and like associates that viewing key with the business card. But I just want to have this MVP version for a demo. So now if we have the correct viewing key, we should be able to see the card that we just created. All right, that's all that this does. That's all that we're doing here is just showing privacy tech at work. So let's dive into the code. Stop sharing. Okay, so we have three main folders in this repository. I have a React folder. This is just where I have my Tailwind and React code. We're not going to be looking at that today. We're going to only be looking at two primary folders, which is our node folder and our contract folder. And primarily, we're going to be focusing on the contract. So node, this is where I actually use secret.js to then see this secret.js is our only dependency in here. This is where I use secret.js to upload, instantiate, and execute this smart contract that we're going to be developing today, and also query it. So this is like, if you're just like want like a full crash course of just like how to go from like nothing to being able to like actually get your contract onto a test net, definitely go through this repository because it has all of the information you need to do exactly that. But let's start with our smart contract. So what I like to do, this is, man, I'm just trying to put myself in the headspace of everyone here who said that they have zero Rust experience, because it's probably a little bit daunting. Let's see. I think the best way to think about this is, so in our contract folder, you can ignore most of this. Most of this is just kind of like boilerplate. What we need to look at is, maybe we'll start with this. So our cargo.toml file, this is just like in JavaScript or TypeScript, your package.json file, like all of the dependencies you need to actually develop your smart contract. So all this is doing, just think of this as like your package.json file. This is just saying, hey, we're using these dependencies in order to be able to pull these in to write our smart contract. And most of this is just like totally standard stuff, right? So if you're developing in the Cosmos, you're going to be using this stuff like CosmWasm, STD, CosmWasm storage, this CosmWasm schema. This is just basic boilerplate stuff that, so that like if you were to go to Secret Networks getting started documentation that I linked and start with like the basic counter smart contract, you would have all these dependencies already in there. And then from there, you're just kind of going and adding what you need. For example, we're using the secret toolkit, which I linked to that GitHub repo earlier. And we're using certain specific libraries from that toolkit, like storage, viewing key, crypto, utils. So because I've pulled this in with these features, it means that now we have access to those repositories that I was showcasing earlier. That's all this means. So don't worry if this seems like a lot. So that's where you configure what you're actually importing, right? All you really need to know when writing a CosmWasm smart contract is this source folder. This is like these are our main files to actually write this smart contract. And the main pieces that make up a smart contract in the Cosmos is your contract.rs file, your message.rs file, and your state.rs file. And one thing I want to flag before I go any further is, if you're new to the Cosmos, one thing to understand about it, and in terms of the way it's different from Ethereum. Well, actually, does anybody want to tell me? Does anybody here want to explain like why they think Cosmos and Ethereum is different on like in terms of like a tech stack level? All right, everybody's very shy in Turkey is what I'm learning. Somebody wrote account model in the chat. So I think the biggest difference in kind of like
Is it because of the consensus mechanisms in Cosmos mainly?
Oh, can you explain what you mean, Karen?
I believe that there's a proof of stake mechanism in Cosmos called Tendermint or something that was different, and it was about like Byzantine attacks or something. But I don't remember that.
Okay. Yes, actually, let me just go into the docs and link you guys to something that I think is like a really good ecosystem overview. This is definitely something to read after this. This is Tendermint consensus, what Karen was just talking about. So that's just like the underlying way in which the blockchain is functioning. So like, for example, in Tendermint, if 1/3 of nodes fail, as long as there's 2/3 of the validators, then there will be consensus, as opposed to like Bitcoin, where Nakamoto consensus is subject to 51% attack. So this just kind of goes into like the underlying, like what Tendermint actually is, how the blockchain is functioning. But I think the biggest difference between Ethereum and Cosmos is sort of Cosmos's app chain thesis. So whereas on Ethereum, every transaction, it's all being finalized on this on the same L1, right? On the same layer 1 of the Ethereum blockchain. And then now they're starting to have things like sharding and ZK rollups on layer 2s to try to like deal with some of the congestion that's happening on the blockchain. What happens with Cosmos is it's called the app chain thesis. And so instead of just having one underlying blockchain where all transactions are resolved, the difference is there's all of these independent sovereign blockchain chains that are using the same software development kit, that are using COSM WASM to write their smart contracts, and using the same consensus, this Tendermint consensus that is how the blockchain functions. So they're all using like the same rules, but they all exist independently. So you can think of them as like a bunch of like almost like nation states essentially, that are then communicating with each other and then sharing state, sharing. And so what this allows for, right, is that every chain can do extremely specific things and have much quicker execution finalization times, right? Because instead of like having to, like on Secret, for example, it's a privacy focused blockchain, but then other blockchains who want to use Secret's tech stack can pull Secret's blockchain in through the inter blockchain communication system through IBC. This probably is a lot if you've never heard of anything about the Cosmos, but hopefully that makes sense. Basically, so the main difference is just that every blockchain in the Cosmos is independent, but can communicate with each other and share information. And so it just allows for like faster execution finalization and more specified purposes for each blockchain. And I don't know if you guys have been following kind of like the news of what's been going on with GMP, something called general message passing, but that looks like to be the future of the way in which blockchains are going to be communicating with each other. So like, it seems like very soon, if you're building on the EVM like Ethereum virtual machine, or you're building in Cosmos, we're going to be able to communicate with each other across ecosystems, which will just be huge in terms of what it does for like proliferation of blockchain communities, I think. Anyways, it's a lot of information. Let's dive into this contract. So the three main pieces of this is we have a contract file, a message file, and a state file. State is where we're actually saving the information into our contract state, right? Like this is like when we create a card, this is where we're actually accessing that card when we query it on the blockchain. We have the contract file, which is where all of the logic of the smart contract execution is actually happening. So we'll look at that as well. And we have our message file. And these are the messages that the contract is actually executing. So in COSM WASM, there's three primary types of transactions you can send to a smart contract. There's the instantiate function or message, which this is the transaction that's used to deploy a new instance of a smart contract. So instantiate, that probably sounds familiar if you've developed on Ethereum. Because when we upload a contract to the blockchain, it's just stored as a piece of code. And then the instantiate transaction is what allows us to actually create a new instance of that contract by initializing its state with our wallet address. The other two kinds of messages are, and when I say message, you can think of message as synonymous with a transaction. So it's just whenever we're executing a transaction with the smart contract, that's a message. The execution message, that's what we're gonna fill out right here. This is what the contract is actually doing. These are, so like I said, the three things that we want to be able to do with our contract is create a card, burn a card, and create a viewing key. That's all this contract is doing. That's what's happening in this execution message. This tells the contract what actions to actually take. And the third type of message is a query message. And that's just querying the state of the smart contract to, see that the transactions we've executed to make sure that they've actually happened, right? We can query the state of the smart contract. And something to note, which you guys probably already know this, is just that when you execute a transaction, that's changing the state of the smart contract. But when you query the smart contract, it's not actually changing the state. It's just accessing the information that exists in the state. And as a developer, like when I'm working on a contract and I'm thinking about starting on a new project, I always like to start with this message file, right? Because that's what your contract is actually doing, right? So like when I set out to make this business card application, I was like, okay, what do I want it to actually do? I want to be able to create a card. I want to be able to delete a card, and I want to be able to create viewing keys so that people can access my cards. So let's, I guess, start just by filling out this execute message enum. So we want to be able to create a card. And when we create a card, we want to create it at a specific index, right? That way we can have like an array with infinite amounts of cards, and each card exists on a specific index. So I'm creating this create message where what we need is a card that goes into it, and then also the index of that card. We need to be able to burn a card, which means we need to be able to know which index that card is at so that we can delete it. And then we need to be able to generate a viewing key. And most of this code is already filled out, but I just want to fill in a few things to kind of just get your brains thinking about the way in which you might write your own smart contracts in the Cosmos or on Secret Network. Okay, maybe, oh yeah, and so again, remember I said that there's three kinds of messages. There's an instantiate message, an execute message, and a query message. So every contract has to have an instantiate message if you're gonna use that contract on the blockchain. So even if it's empty, right? Like it would be perfectly okay to have this be empty, to have nothing here. What I'm doing though is just creating a string that I instantiate my smart contract with that I can use for entropy if I use like a random number generator. But this actually is not required for what we're doing today. So every contract needs an instantiation message, the execution message. This is what we're actually doing, and then the query message, right? So this allows us to be able to actually like query the card with the viewing key at a specific index. That's what, when we queried the card in the demo, that's what this message was doing. That was the query message. Does anyone have any questions about any of what I just said? Let me just look at the chat real quick. No? All right, I'm gonna keep going. So maybe you're like, okay, that's fine and dandy to create a card, but where does this card actually come from, right? Like, so great question, my Turkish audience. This card comes from, we have to import it using a crate, right? So to access what we define, the variables we define in another file, for example, the way you import that in Rust is through something called crates. So we say use crate state, that's this file right here, state.rs, card. So we're pulling this card struct from our state. And the card struct is just what we say the card wants to, what we want our card to actually include. So for in the demo example, it was like name, address, phone number. So let's just fill that out so you understand that that's what we're importing in this card struct. Let me just, okay. So now if we go into our state file, we're going to fill out this card struct. And we just have a few things in this state file, right? This is a super stripped down state. really all we need is this. We have a key map that is a card viewing for our card viewing keys, and we have a key map for our cards that is just associating each card with an index. And I'll show you how we actually implement this and use it when we get to our contract logic. So let's fill out our card. So all that we want to do in this struct is this is the information we're actually storing to our smart contract, right? Because we're in our state file. I'm sorry, people keep joining and I keep having to add them to the group. There we go. Okay. So this is the information we're actually storing in our business card, okay? So let's start, let's just say we're gonna have a name, which is a string, an address, which is a string, and a phone number. Okay, and so this is what we're going to be storing to our smart contract, just a name, an address, and a phone number, and each of those variables are strings. And this pub, maybe you're like, why does it say pub? Like, is that short for public? I thought that all of this is private. Yes, it is. This is just like for how Rust refers to like the ability to access variables within the smart contract itself. But this data, just because like we're using a public struct in Rust, doesn't mean that this is publicly visible on the blockchain. It's still, this smart contract exists in the trusted execution environment on secret networks, so no one is able to access this information unless they have our viewing key, right? All right, so does that make sense? So we define this card, this struct in our state file. Then in our message file, we import that card from our state crate so that then we can access it in our execution message, right? So think about this flow, right? This is where the information is being saved. This is the action that we actually want to be able to take. And now we can go into our smart contract. And if we go to the imports up here, we see we're importing our state, right? We're importing the card and those other variables we defined. And we're also importing our message crate and those variables we defined, like our execute message, our instantiate message, and our query message. So now we're able to use this state and these messages that we defined in the actual smart contract logic itself. I'm gonna take a sip of coffee. Let me know if anybody has any questions before we dive further. I'm just gonna check the chat real quick and see if there's any questions. No questions, okay. Let's keep going. Okay, let's see what we got here. Trying to remember what I left for us to do. All right, I think this is good to understand. So each of those types of messages that I mentioned, the three messages, right? There's the instantiate message, the execute message, and the query message. In our smart contract, they each require their own individual entry point. So this function is just the function that the smart contract calls when we instantiate it after we upload it to the network. That's one entry point. The next entry point is all of the execution messages that are actually happening, which is the create, the burn, and the generate viewing key. And then we have the third entry point, which is our query messages, which is how we actually query the state of the smart contract. And yeah, this is where we're writing all the logic to actually access this information. So one thing I think you should understand before we dive deeper is there's this one function, right, which is the execute message, and then it can do different things based on the messages that we define in our message file. So in our message file, we define three messages, right? We define the create message, the burn message, and the generate viewing key message. So now using this match statement, depending on which of these we call in our smart contract, whether we call create, burn, or generate viewing key, it's then going to execute a different function that we need to write. So we have our create card function, we have our burn card function, and we have our generate viewing key function. And I think I've written out all of these in here except for maybe create card. So let's just do that real quick so you can kind of see some Rust's logic and how we would do that. So this is like boilerplate right here. This stuff right here, these variables. So what this is doing is we're going to create this create card function. And in it, the parameters that we're passing is the card and the index, right? Because that's what we defined in our message. We said that it has to have a card and an index. And then we're also passing this depths and this info. And if you ever want to just like in a Rust smart contract, go deeper into what these actually are, depths holds all of the external dependencies of the contract. So this is like the storage information on the blockchain, okay? And info, message info, this is like this is the wallet address that initiated the action. So we can see who's the person that's actually calling this function, right? Which the reason why we include this information in this function is because we're going to use that information to store our business card information. And this sort of stuff right here, this is part of the Cosmos SDK. So like the more you dive into developing with Rust and CosmWasm, the more you'll start to see that this is just like boilerplate code, and this will make a lot of sense like as soon as you start to just dive into learning CosmWasm. Okay, let's do it. So this create card function, all that we need to do is save a card to a particular index in the smart contract, right? And associate that card with the user who is creating the card, right? With the wallet address that is creating that card. That's why we're accessing this message info parameter, is because we want to say, hey, whoever calls this function, let their wallet address be, we're going to say, hey, that's the guy who owns this card, and they're doing it at this particular index. And I want to just show you again in our state, what we're importing is this user cards key map that is just associating, it's just a key map that associates a card with an index. And what we're going to do in this create card function is just associate the wallet address that calls this function with that user cards variable. So let's do that. And this is like going to be so simple, it's going to blow your mind, because I think it sounds kind of complex what I'm saying, but it's actually very easy. So add suffix is just a method in the secret toolkit. And this is just used to associate our key map with a user. So we're going to say user cards, add suffix, info.sender as bytes. Okay, so that's just associating, that's just in this user cards key map, adding the info.sender. So adding the wallet address that's calling this, associating that with this variable. And then we also want to now insert this card into our storage. So we use the insert method and say depths.storage, because we're accessing the, that's why we have to include this depths variable. And we want to include it at an index, and we want to store the card, right? And this question mark that I'm writing, all that this is doing is saying that if this transaction is unsuccessful, revert the transaction so that it doesn't go through. This is just like a Rust thing, specific to Rust, where it just decides whether or not it should continue or break, okay? And then, I don't think we need this. If the transaction doesn't revert, if it doesn't break, we just return a default response. Okay. And then let me just add some more people into the group who want to be admitted. Does that make sense, what I just showed everybody? Does anyone have any questions about what I've shown so far? There are no dumb questions. The way we learn is through just asking all the questions. No questions? Okay. So I want to just show you one other thing that's like actually on the smart contract level before we actually then compile the smart contract, upload it, instantiate it, and execute it. Because we're kind of coming up on the hour. Somebody wrote, understanding and applying the structure is too hard. Fear not, Alperin. I was once, not even that long ago, less than a year ago, I was an Ethereum developer who learned all this. So if you look at those resources that I shared in the chat and in the Google Slides, this will all just make sense or start to make more sense the more you look at it. So one thing I want to just show you guys that I think is so great is, remember when I was showing you the code for the secret toolkit? And it was that big repository, right, in GitHub? What it's doing behind the scenes is a bunch of programmatic math to generate a cryptographic password. But for us developers, all we have to do to actually use that is import in our cargo toml file that viewing key feature. And now in my contract, right, I say use secret toolkit viewing key store. Now when I go to generate a viewing key, all I have to do is say let viewing key equal viewing key create. This is the API that Secret Toolkit developed for us. And then in that creation, all we need is to store it in our contract. We need the info of who's sending it, the environment parameter, and just an entropy string. And then we're good to go. This is going to generate that unique password for us. And this just like teeny little one single line of code, right? So I just want to make sure you guys understand that that resource exists. All right, so the rest of this is built out. I think for time's sake, I just want to show you guys how to compile a contract now on Secret and then upload and deploy. So in the resources that I shared, there's the Secret Network docs that specifically I shared the Getting Started resource. That goes through all of this too. So definitely if you're interested in this, take a second look at that because I'll go through everything step by step on a really low level and use like a simplified counter contract to teach you all of these things. But basically before we upload a smart contract to the network, what we have to do is generate the WASM file of the smart contract. That's what we're actually uploading to the blockchain. And to do that, you can there's like a script you can run that optimizes the smart contract and optimizes the WASM file so that it's like the smallest file possible that we're actually uploading to the network, which is just good practice for when you start to upload to mainnet. You don't want to upload, a huge contract if you can help it, because it's going to cost a lot of gas. So what I'm doing right now is just running this this optimized script to create this optimized WASM file. And let me just make sure I have Docker up and running so that I can do this. 1 second. Look. Okay. 1 second. I'm opening Docker right now, which is what we use to create this optimized WASM file. Okay, I think we should be good to go. So let's see. So now what's going to do is just go through all of our code. I think it's because Docker's still opening. Oh, I got a CD into this contract directory. You may not be able to tell from my calm composure, but every time something doesn't work when I'm doing a live demo, I have a mini heart attack. All right. So what it's doing right now is just generating the WASM file. It's taking all this information that we just wrote in our smart contract, and it's going to store it in one file for us in this contract folder. And then we're going to upload that to Secret Network Testnet. So let me show you how we do that while this all compiles. Okay. So our node folder, this is where we're now using JavaScript to upload, instantiate, execute, and query this smart contract. So all this is just I created an empty package.json file, and I added I npmi'd secret.js, which is what we use to interact with our smart contract. So that's all you got to do. It's just this one thing, secret.js. The other thing you got to note is just add type module to your package.json file so that you can interact with this code properly. So I have one file here where I'm doing all of this, index.js. So now that we've installed secret.js, we're able to import specific things to that, like our secret network client and our wallet. So let me just comment some of this out. Make sure none of this is going. All right. So our secret network client, this is what we're using to actually to communicate with the blockchain, right? And what's so incredible about this, to me, it feels like magic, is like a few lines of code here in JavaScript, and now we're able to communicate with the secret network blockchain, right? Which is communicating with everyone across the world. To me, it's like the magic of blockchain. So I have a wallet address, right? This is literally just my 12-line mnemonic. And then using that, I'm able to communicate with the blockchain. And all I have to do is specify my wallet address, as well as the chain ID and the URL of the network. So like this right here, this secret.js config, this is for testnet, because we're using the testnet chain ID, which is Pulsar2. If you wanted to do this to upload this contract or any contract you make to mainnet, you could use this exact same code, every single line. All you would have to change is the chain ID and the URL to be the mainnet URL and chain ID. So let's just let me just show you the fact that we have our wallet successfully querying the network. So if we just console.log secret.js, we should then return this secret network client. Let's see. Oh, I can comment this line out. Okay. Look, so this is just showing us that we successfully are communicating with the network, and it's telling us this is the chain ID, and it's saying this is the address of the wallet that is speaking with me, right? Okay. Also, just if you guys are new developers, make sure whenever you're doing test stuff, right, that you create a wallet specific to just development. Like this wallet that I'm using, this is my testnet wallet. So it has no real money, no real funds on it. It's all just testnet funds. So like if someone were to see this, some nefarious actor who's currently watching this stream were to see my seed, it would not wreck my life, right? I would lose some testnet tokens. That's just like best practice. You never want to actually use your like wallet that you store funds to be interacting with your smart contracts. Okay. So let's see if this, oh wow, it's still compiling. Okay, taking a minute. As soon as this compiles, we're going to then be able to take that WASM file and upload it to the blockchain. So let's just give it a second. Any thoughts or comments on what we've learned today so far? We're going to be wrapped here in like the next 10 minutes. So any questions I can address right now while this compiles? Is it who? I'm just curious. Comment in the chat where you guys are joining in from. I've been to. Oh, here we go. We did it. All right. So now that we have this optimized WASM file, it is saved here, right? This is where it's stored. That's what that upload script does that I just ran. Somebody commented, can we start a local network at Cosmos? When you say local network, do you mean like create your own chain? So the short answer to the question, can we start a local network at Cosmos? Yes, you can build locally. So like if you don't want to be using the testnet, there's actually something like in secret called local secret, where it's a developer environment in Docker that mirrors the testnet and the mainnet, but you're only interacting with it by yourself. And if you go to the getting started resources that I linked, all that information exists in the docs. So you can just build locally. Great question. All right. So what I'm doing is creating a variable that allows us to access this WASM file that we just generated, right? So after I ran that optimize script, it generated this contract.wasm.gz file in our contract folder. And now I just have this variable that is accessing that file. And from here, we're going to use our secret network client to upload that file to the testnet. So this is like the information that the transaction actually contains. We're saying, hey, store this code, which is has our sender, my wallet address, and then just the WASM bytecode, which is what we just optimized. And we have to specify a gas limit. All of this information, how to do all of this, it's all in the secret docs. So don't be overwhelmed. All of this information exists. This is all basically just boilerplate. And somebody commented, what do you prefer, local or testnet? I like testnet just because I think I like it because it's like I can, for example, like I can upload this contract right now, and then everybody who's on this call, everyone who's watching, it doesn't matter where you are in the world, probably 90% of you guys are in Turkey. I'm in New York City. I would be able to create a card, and then someone who's watching this would be able to access my card on testnet. And to me, that's just like unbelievable that I can just do this demo in New York City, upload this to the blockchain, to the testnet, and then here we are being able to communicate with each other across the world. But if you're just wanting to just like test things by yourself, local is fine. One sec, I'm admitting somebody to the call. All right, so let's try running this upload script and see how it goes. Oops. All right, commenting this out. Make sure nothing else is commented. Cool. Let me just clear my terminal so we can see what we're actually doing. Oh, here we go. All right, so all we're doing is just running this upload function. And if it's successful, what it should return is the code ID of the contract and the contract hash. Great. So now we have a code ID and a contract hash, and we're going to use that to now instantiate our smart contract, okay? So let's just store those as variables. And a contract hash is specific to secret network. So generally, if you write contracts on another chain in the Cosmos, you will not have the contract hash, you'll just have the code ID. This contract hash is specific to the SGX, to the secure enclave environment that Secret uses so that we have private information. And it's just one additional detail we need to instantiate our contract. So I'm going to add this here. All right, so now we're going to use this code ID that was just returned from uploading our script and this contract code hash, and we're going to use that to instantiate this smart contract. All that this transaction has, again, remember I said in our instantiate message, I have an entropy seed. So mine just says, this is my entropy dude. You can make it whatever you want. We have the code ID. We have the sender, which is my wallet address. We have the contract code hash. We have the init message, which is that init message. And then we have what we're labeling this. So I'm just labeling this secret business card demo with a random string. And let's see. And if this is successful, and we run into no problems, then we should be able to instantiate and interact with this smart contract on testnet. So let's try to do that. All right, so this is the address of the contract that we were just looking at. So now to interact with the smart contract, right, all we got to do is execute transactions using this contract address. And I hope you're starting to see like the magic of blockchain. I'm sure you guys already know the magic, but it's just so cool. So let's try to execute a transaction with this contract address that we just had returned. So I told you instantiate is one of the kinds of transactions. Now we can actually execute messages. So remember we said what we're able to do is create a card, create a viewing key, and burn a card. Let's create a card on the smart contract. So let's just make the name. I want to use your guys's university group name. So we'll just go like this. Hell yeah, right? Address, Turkey. Okay, and we're going to create it at index 0. So let's try this. Create card. Make sure there's nothing else here. Okay. All right. And all this is doing is just console logging the transaction hash and all the information that is with that. So we know that we have a successful transaction. Now remember to access that card, because now this exists in the smart contract, right? But nobody can access it unless they have the proper viewing key. So in order to access it, we have to create a viewing key. So let's do that. Let's see. Okay. And if this is successful, it should return to us a viewing key specific to that card. Great. And so see how, remember in the way the contract logic is defined, we generate a card at a specific index. And then the logic for the viewing key function is that we also generate the viewing key for a card at a specific index. So see how this index, what I'm passing in this JSON message, we're saying the viewing key is for index 0. And when I created the card, it was also the card was created at index 0. All right, so it returned to us this viewing key. Now, if I have the proper viewing key, it should return to us this card. Okay. So actually, before we do that, let's use a viewing key that's not the correct key, just to see what happens. I want to make sure I define the logic correctly. So this is a viewing, you shouldn't be able to access this card if you don't have the proper viewing key, right? So now we're saying query the card. This is the third type of transaction we can do, a query message. We're saying get the card at this index with this viewing key, and we're using the wrong viewing key. So it should fail, one would hope, if I wrote this correctly. Let's see. All right, you don't have the correct viewing key. Amazing. I wrote this error into the smart contract itself. So if anytime you have a wrong viewing key, it returns this error. So now let's try using the correct viewing key that we cryptographically created with Secret Toolkit. So this here. All right. Now we're using the correct viewing key for index 0 with that's specific to that card. And not only is it specific to that card, it's also specific to that index, to that card, and to that user's wallet, right? Because if I were to make this card, if I used a different wallet address here with the correct viewing key and the correct index, it wouldn't work because anyone can access this smart contract, but each person's wallet is communicating with the contract and has a different relationship to it. All right, let's see what it returns. There we go. There's our card, ladies and gents. All right. Awesome. So I think we're at time here. That's an hour and 13 minutes. That's the demo. I hope this has been informative, educational, and that you feel like you've learned something today. I'm going to turn my camera back on. So let me know if you guys can. There we go. It probably feels like an information overload, which is a good thing. That's how it always feels like. Every time you're learning a new ecosystem, it feels like you're drinking from a fire hose. But yeah, it's really incredible what you can do on Secret Network, and the ability to create programmable privacy and the way you're able to do it on Secret, I haven't really seen on any other network. And I think it's a really unique value add to the blockchain ecosystem. If you guys are interested in learning more, definitely check out the resources that I linked in the Google Slides. And please come through to the Discord developer calls on Mondays at 12 p.m. Eastern time, because that's how my journey got started. And you just, day by day, you just learn a little bit each day. So yeah, thanks everybody. I've been Sean Conrad. If you have any questions, let me just drop my Twitter actually, so you guys can follow me. And if you have any questions, just let me know and I'll get back to you as soon as possible. There you go. And yeah, thank you so much to your organization for having me. It's a real pleasure to be able to speak with you. And it's just exciting that, across the world, people are so excited about blockchain, and especially university students. All right. If there's no other questions, I'll wrap it there. Thanks, everybody.